Log equations are equations that have a variable inside of a logarithm. It might be x, it might be other variables, but the point is the variable is trapped inside of there and we have to get it out to solve. We have two basic categories of log equations. We have one where everything is inside of a log. There's all logs on every term. The other one over here, well, I've got a log on this side, but over here it's just a plain number. So you want to make sure that's what you use to distinguish which type of strategy you're going to use to solve. And our two strategies are these. If there is no constant term, so in other words there's logs everywhere, then you combine as needed so that you have a single log on the left and a single log on the right. And then we use the one-to-one property and equate the insides. We basically ignore the log and just equate what's inside of them. Okay, so we're going to combine these using the quotient rule and the product rule, whichever the case might be. On the other hand, if I have one like this where there is a constant term, then we can't just drop the log. We can't just make it go away. You're changing the whole meaning. So instead, we use the definition of logs and we convert this from the log form to the exponential form. We take the 3 and raise it to the second and equate it to the inside of the log. All right. Sometimes we have to condense. This example I didn't have to, but others we may need to condense so that you have a single log and then you rewrite it. So let's look at some examples. Taking this first one, we're going to combine. This is an addition problem, so we're going to use the product rule, which means I'm going to take the natural log of 4x, and over on the other side we still have our natural log of 22. Because these are both natural logs, we basically ignore it and just equate the 4x equals 22 and solve. Now, there is a really important note that when you are working on log equations, sometimes you do everything right, but it's not a true answer. It's what we call an extraneous answer. And the way we're going to recognize that is we're going to take our answer and we're going to plug it in the original equation and see if we get the log of 0 or a negative. If so, then it's a false solution. If not, we're going to assume we did our work right and that it's a correct solution. Alright, so this one's a good one. Let's take a look at this example. Now this one, I can't just drop the log because I don't have a log on the other side to ignore. So instead, I'm going to rewrite, and 3 is going to be squared, and that's going to equal the 5x. That means x is 9/5. If I put the 9/5 up here, I still have just the log of a normal number, so I don't have to say that it's extraneous. I say it's a good solution.